graphing in this section 5.3, and we are going to look at what a radical looks like on a graph. So your equations now, your functions, are going to have either a square root in them or they're going to have a cubed root in them. And those are the only roots that we're going to do. We're not going to do fourth roots or fifth roots, but we're just going to do square roots and we're going to do cubed roots. Okay? So, like any other function that we want to graph, whether it's a linear function or whether it's a quadratic or whether it was a cubic, we're going to make a table of values and we're just going to plot the values. If I want to graph y is equal to the square root of x, we want to be selective on the values that we plug in for x because we want to take things that have square roots. I don't want to put a 2 in here for x because the square root of 2 is a decimal. So I want to put things in, I want to choose values of x that actually have square roots that come out nice. So these are the reasons why I chose 0 for an x, I chose 1 for x, I chose 4 for x, and I chose 9 for x because those have square roots. Okay, so if I put a 0 in, what's the square root of 0?
0.
That's just still 0. What's the square root of 1? 1. What's the square root of 4?
2.
2. And what's the square root of 9? 3. So you're going to plot those points on your graph. So I'm going to plot 0, 0. Go ahead and do that. I'm going to plot 1, 1. I'm going to plot 4, 2. And I'm going to plot 9, 3. Now, can I take the square root of negative values over here? Can I put in a negative 1 and a negative 4 and a negative 9? No, because when we take the square root of something negative, we get an imaginary number, right? So we can't put negative values in. So the graph starts at 0, 0, and it only goes one direction.
That seems easy.
Yes, it is. And so if I asked you about the domain of the graph or the range of the graph, remember the domain refers to your x values.
All real numbers above 0?
That's right. You'd say x's are greater than or equal to 0 because we can't put in negative x values and take the square root of it. And then my range value, is there anything that I can take the square root of and get something that's negative?
No.
No. So we would say the range, y's are greater than or equal to 0 as well. And all square root functions are going to have the same shape as this. It's going to start at a designated point, and it's only going to go one direction. Now, there are things that we can do, like we could multiply outside of this radical. We could add or subtract things outside of the radical or underneath the radical. That's going to move this around the graph, but the shape of it is always going to just look like this. Okay? That's what makes this, I think, pretty easy. Every time you see a square root, it's going to have that general shape. Now, what happens with a cubed root? Okay, so a cubed root, we want to find values that have a cubed root. So 0, we can take the cubed root of 0. We can take the cubed root of 1. We can take the cubed root of 8. The next value that I could take the cubed root of would be 27. Now that gets a little bit high and off of the graph. So we want to stick to these values. Can I take the cubed root of negative numbers?
Yes.
Yes. So that's why you see negative values for x in your table. So if I want to take the cubed root of negative 8. Okay, what is the cubed root of negative 8? Negative 2. Okay, if the radicand is negative, then the root's going to be negative. So this would be equal to a negative 2. Whereas if I took the cubed root of a positive 8,
2.
that would be a positive 2. So you're going to go here, you can put 2 where it's 8. Okay, if I take the cubed root of negative 1,
-1.
that's a negative 1. And when I take the cubed root of positive 1,
1.
positive 1. And the cubed root of 0 is just 0.
0.
And if you're unfamiliar, like those aren't just coming to you, you don't know what those are, use your calculator. Okay, let's plot these. So -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. When you connect this, you are connecting it. It's almost like an S, but it's kind of, this one's flattened out, but it looks like an S. And cubed roots are always going to have this shape. If I talked about the domain and the range here, what values can I plug in for x? Can I plug in negative values?
Yes.
Yes. And this arrow means it's going to keep going in the negative direction. Can I plug in positive values? So this would be all real numbers. X can be anything. And your range?
Same thing.
The same thing, because I got negative y values this time, and I got positive y values this time. And as this graph goes out, it's gonna go up, 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 ever so slightly, but it's gonna keep going up, so it doesn't stop. So this is gonna be all real numbers as well.
Wait, with the 2 lines, that means all real numbers? Or is that just
Yeah, that's the
real
symbol
numbers?
for real numbers. Positive and negatives work. Okay, now those are what we would call the parent function. That's the general shape, because there was nothing multiplied, nothing added or subtracted. It was just the square root of x or the cubed root of x. That's the parent function. Now we are going to, you're going to encounter, you flip your page, you're going to encounter where we might have some addition underneath the radical or outside of the radical, addition or subtraction. We also might have some multiplication that you encounter. It's just a matter of plugging your values in and doing the math. You're still going to create this table of values. You're going to pick out x values to plug in, and you're going to see what y values that you get in return. Okay? If we can only take, this is where you got to think a little bit about the values that you want. When we follow order of operation for this, that x plus 1 is going to have to be done before you take the square root of it, because it's all underneath the radical. So what kind of values can I take the square root of? Well, we know we can take the square root of 0, we know we can take the square root of 1, we can take the square root of 4, and we can take the square root of 9. Those are values that have a nice square root. So what I want to think about is, what can I plug in for x and then add 1 to it and get one of those numbers, because that's when I take the square root. So for example, if I put a -1 in for x,
No.
-1 plus 1, that would be 0. And I can take the square root of 0 and then subtract 3. I get -3 out of that. Okay, if I want it to be a 1.
Wait, so it's -3 not under the thing?
It is not underneath the radical.
That's what I was.
So you take the square root first, and then you subtract 3.
Okay, never mind.
Okay, if I put a 0 in here for x, and I did 0 plus 1, I have to do what's under the radical first, so 0 plus 1 is 1. Then I take the square root, which is still 1, minus 3. I get -2. If I put a 3 in here for x, I choose 3 because underneath the radical I have 3 plus 1, which is going to give me that 4. What's the square root of 4?
2.
Minus 3. Get -1. And then the last value I'm going to plug in is an 8. Because 8 plus 1 under the radical will give me that 9. And the square root of 9 is?
Wouldn't it be 2?
3. Minus 3 is 0. Now let's plot those 4 points. Okay, so if you just start right here and you're just going one direction like that, that has the same shape as the graph we did on the previous page that was square root. It's just that it's been moved on the graph. Instead of starting at 0, 0 like it did on the last page, it's starting at -1, -3. And if you look at the values up here, you can see those values in the equation. You take the opposite of what's being done down here, that's the -1, and you take that value, -3, that tells you where to start your graph. But again, it has the same shape. And I would tell you how to, when you graph any function, you don't remember what the shape is supposed to look like, I would just you're just making a table of values. Plug your values in, see what you get, plot them out. But it is helpful to know what shape you think it's going to be before you start. Okay, and then if we did example 4, this is a cubed root, so what kind of shape would you expect to get? That S, right? Because it's a cubed root, you would expect it to be an S. Because we're taking the cubed root, the values that we want to look at, we can take the cubed root of -8, we can take the cubed root of -1, we can take the cubed root of 0. These values are all nice values to shoot for because they have perfect cubed roots. There's no decimal. But again, you got to think about you got to do the operation under the radical first before you take the cubed root. So for the value for x that I would plug in here, if I want this to be a -8, I would have to put in a -6 for x. Because I'd do the -6 minus 2 to get -8. Then I take the cubed root of that to get -2 plus 1. I get a -1. If I want what's under here to be a -1, I would have to plug in a 1 for x. 1 minus 2 is -1. When I take the cubed root of -1, I get -1 plus 1 is 0. If I want this to be a 0 under here, I'd have to put a 2 in for x. So 2 minus 2 is 0, and the cubed root of 0 is 0 plus 1. If I want it to be a positive 1 under here, I'd have to put a 3 in for x. So 3 minus 2 is 1. Cubed root of 1 is 1 plus 1 is 2. And if I want this to be an 8 under here, I'd have to put in a 10 for x. So 10 minus 2 is 8. Cubed root of 8 is 2 plus 1. I get 3. And you're going to plot those 5 points. -6, -1. 1, 0. 2, 1. 3, 2. 10, 3. And it might look very random to you right now, but we know what kind of shape it's supposed to be. So we're going to start over here. We're just going to make that flat S going through. And again, this point here is kind of where the middle of it, where it goes up and to the left from that, to the right from that. And that point is at 2, 1. And you can see those values in the equation. The 2 and the 1 are in that equation. But again, we're just going to keep making a table of values. But again, it's always helpful to know what's the shape of the graph. If it's a square root in your function or your equation, you're just going to have one part of it, one side of it going one direction. If it's a cubed root in your equation, then you're going to have this flat S.